All right, this is it. This is the last video and the last activity on Kepler's laws. Now we're going to do Kepler's third law. Kepler's third law states that the ratio of the cube of the average distance of any planet from the sun to the square of its period of revolution is a constant. That sounds like math, and that's exactly what we're going to be doing in this activity. Before we start the math, though, we need to look up some information. So you need the distance that each planet is from the sun, and that needs to be in the units, astronomical units. And you need the time it takes for the planet to revolve around the sun once or orbit the sun. And you need those values to be in Earth years. So you're just going to do a Google search, and then we will start the calculations. So just go to Google. And we're going to type in average distance planets, distance from the sun in astronomical units. Right, and there's some values right there. All right, we need some more temperatures. There we go. There's a chart. So there we go. Distance from the sun in astronomical units. There's Mercury, Venus, Earth. So I'm just going to write them down while I'm looking at the screen here, and then you can see where I put them. I am not going to do them all. I am only going to do the first 3, and you can do the rest. All right, we also need the period of revolution, and that information is right here. So what we need is the values in Earth years, and you can see all of these, almost all of these, some of these are given in days. So Mercury, Venus, and Earth and Mars are given in Earth days. We need them in Earth years. Jupiter, Saturn, Uranus, and Neptune are given in Earth years. So for Jupiter, Saturn, Uranus, and Neptune, you can just write those numbers down on your paper, but the other ones have to be converted. So I'm going to write down these values. I'm going to round that first one up, Mercury, to 88 days, because it's almost that. And the next one, I'm going to round it up to 225 days. And then Earth is 365.25 days, but that's 1 year, and we need the numbers in years. So I just wrote that down. So I've got all my data, and I've added it to my paper. Now we have to take care of this because we want our units in years. So I'm going to convert Mercury into Earth years by taking the 88 days and divide it by 365, because that's how many days are in an Earth year. And that's 0.24. That's the value we need. And then I'm going to do the same for Venus. 225 divided by 365 is 0.62. All right, and you're going to look up all the other values, and I'm just going to do the first 3 for calculations, for examples, and then you're going to do the rest of them and answer that question at the bottom. All right, so we're going to calculate some ratios, and our ratios are the average distance cubed and the period of revolution squared. So I'm going to start with the distance, and it's cubed. So I'm going to take 0.39 times 0.39 times 0.39 equals, and I get 0.059. And I'm going to write it as a ratio, so I need the colon there. And then I'm going to take the period of revolution, I'm going to square it. So that's the 0.24. 0.24 times 0.24 equals, and I get 0.058 for that ratio. All right, the next one is my distance is 0.72, and I'm going to cube it. 0.72 times 0.72 times 0.72, 0.373, and I've got 0.62, and I'm squaring that, and that's 0.384. And then Earth, 1 cubed is 1 times 1 times 1, which is 1. And the revolution squared is 1 times 1, which is 1. Right, and then I'm going to reduce my ratios. So I don't need to reduce the Earth's because it's down to 1 to 1. So what you're going to do is you're going to take and reduce these down so that it's something to 1. Okay, so you're going to take the biggest one, 0.059, and divide it by the smallest one. And you see I got that. So it's 1.02, which is the bigger one, to 1, which is the smaller one. And then I'm going to do the same thing here. I'm going to take the smallest one, 0.0373. Whoops, wrong number. 0.373 and divide it by, do the big one divided by the small one. 0.384 divided by 0.373 is that. So this is the biggest one. So now it's 1 to 1.03. I rounded up. Okay. So those numbers, even though these are not exactly the same, they are close enough to be the same. So you should find that your reduced ratios are very close to 1 to 1. There will be a planet that's an outlier, and we'll talk about that in a future lesson. So finish calculating, look up the rest of these values, do the calculated ratios, and then answer the last question. And that's it. You guys have a good day.